Alright folks, theoretical probability. Theoretical probability is the probability that's based on analysis of all possible outcomes, so you don't actually have to do the experiment. Theoretical probability, also called classical probability, is where all possible outcomes are combined to make up the sample space, or sample set. An event is a set of outcomes that have a common characteristic. So to calculate theoretical probability, we need to calculate the probability of event A happening is when you calculate the number of possible event A's over the total number of the entire possibilities in terms of outcomes. So, where P of A is the probability that event A can occur, N of A is the number of ways it can occur, and N of S is the total number of possible outcomes in the sample space. Now, the sample space of a regular die is 1, 2, 3, 4, 5, 6, as you all know. Now, the event of rolling an even number includes the outcomes 2, 4, and 6. So here is the sample set. Here is the desired outcome that we're looking for. We're looking for the even number, so an event, the event we're looking for. Now, another way to display this data is to use a Venn diagram. Now, a Venn diagram representation of the sample space is to create a box. And in that box is all the samples possible. 1, 2, 3, 4, 5, 6. Now, this is the sample space. This is the entire sample. We have to circle the A. This is the A. This is the desired outcome. We want 2, 4, and 6. This is the event we want out of the total sample space, which is the entire box of information. Now, the complement is the set of possible outcomes not included in an event. Say 1, 3, and 5. That is not the answer we want. So let's go back for a second so you can see. The part that we don't want is known as the complement space. So A prime. So we have A and we have A prime. Now, the probability of A happening plus the probability of its complement has to always equal 1. And this makes sense because it encompasses 100% of the total amount of outcomes possible. Now you can rearrange this equation to have that probability of the complement is equal to 1 minus the probability of A. The probability of A also equals 1 minus the complement. So the idea is you can manipulate the equation in order to solve something. Because sometimes you know one piece, like this, and you can use 1 minus the complement to give you the answer, if you know one part but not the other. Now, back to the original. Let's try an example. Lee has a green hat, a black hat, and a gray hat. She also has green gloves, black gloves, and red gloves. In a hurry, Lee randomly grabs a hat and a pair of gloves. Determine the theoretical probability that the hat and gloves are the same color. So, we're going to look at this problem on the next page. Here it is. And what we're going to do is draw a tree diagram to represent the situation to better understand what's happening. So we have green hat and black hat and gray hat. So green hat, black hat, gray hat. And each one of these is going to go to 3 possible sets of gloves. Green gloves. Now before we continue, if you're going to use short forms, I would like you to identify the short forms. And you can identify it within the problem or give me a legend. This way it's a lot easier if you write right over the problem, so then I'll be able to tell what short forms you're using. So I'm using green H, black H, gray H, GG, BG, RG for green gloves, black gloves, red gloves. So GGBGRG, you're going to write 3 times. Once for green hat, once for black hat, once for gray hat. And when you do that, we now have to identify the possibility of getting a matching set. So to match, we want to get green gloves goes with green hat. So we're going to just highlight. So green hat to green gloves. Next possible match is when we go from black hat to black gloves. So from black hat to black gloves. We do not have gray gloves. We have green gloves, but not gray gloves. So therefore, this gray doesn't have a matching set of gloves. So what's the chances of having matching set of green hat and green gloves, or black hat and black gloves? So they've got to match. Well, that is, folks, probability of matching is equal to 2 out of a total of, and let's count it, 3 here, 3 here, that's 6, 3 here, that's 9. 2 out of 9. So the probability of getting a matching set is 2 out of 9. Example number 2. A box contains 3 bran, 4 banana, 5 blueberry, and 3 carrot muffins. What is the theoretical probability that you will not randomly choose a blueberry muffin? Notice the word not. That's very important to note. So, we will not choose a blueberry muffin. Well, you can either calculate what is remaining, so the complement, or you could use the fact that what is the chances of choosing a blueberry muffin and subtracting from 1 to get the complement, which is what it's asking for. So probability of blue, okay, so we're using B for bran, ban for banana, blue for blueberry, and car for carrot. The chances of getting a blueberry muffin are 5 in 15, because there are 15 total muffins, which is 1/3. Now, the probability of not getting blue, so the complement of that would be 1 minus 1/3. Okay, 1 minus 1/3. Now, another definition we need to look at is odds in favor. What is odds in favor? And if I ask for odds in favor, it is the ratio of the probability that an event will happen to the probability that it will not. Odds against means I'm looking for the ratio of the probability that an event will not happen to the probability that it will. So, the first part, odds in favor, is saying probability of it happening to the probability of its complement. Now, odds against means that I'm looking for the probability of the complement, colon, probability of it actually happening. So be very careful when I'm asking for odds in favor and odds against. A sports commentator claims that the Toronto Raptors have a 60% probability of making the playoffs. Based on this estimate, what are the odds in favor of the Raptors making the playoffs? Well, 60% in favor of, odds in favor means it actually happening. So odds in favor means that it's actually going to happen. So the Toronto Raptors have a 60% chance of it actually happening. 40% against. So odds in favor is 60 to 40, which is 3 to 2. Now, example 4. It is estimated that a golfer has a 20% chance of winning a tournament. What are the odds against this golfer winning the tournament? Well, if he has a 20% chance of winning, we want odds against means the complement of that. So odds against means it will be 80% chance of losing to 20% chance of winning. So he has a 4 to 1 chance. Okay, moving forwards. Example 5. 2 standard dice are thrown. Determine the theoretical probability that the sum is not a 7, a perfect square, not doubles, and a 9. So these are the different possibilities. So what we need to do is throw these 2 dice. So we have one of the die is 1, 2, 3, 4, 5, 6. The other die is 1, 2, 3, 4, 5, 6. Why are we doing that? Because we need to know their sums. Because this is saying it's not a 7, a perfect square, not doubles, and a 9. So we need to deal with all the sums. So the best thing to do here, folks, is to write it out. So we're going to write it out, add all the sums. Here we go. And we have all the sums here of the 2 dice. Okay, now, based on these sums, we can answer, how many of these is not a 7? Well, if we count all the 7s, the not 7s is the complement. So, probability of it being a 7, the complement of that is going to be 30 over 36. How do you know? Well, there are 36 here altogether. 1, 2, 3, 4, 5, 6 out of 36 are 7s. We want the complement, so it's 1 minus 6 out of 36 sevens. 6 out of 36 sevens, which is 30 over 36, which reduces to 5/6. The next part says, determine the theoretical probability that the sum is a perfect square. Which ones are a perfect square? Well, perfect square are going to be numbers such as 4, 9, and that's all, folks. Those are the only ones. So how many 4s and 9s total are there? Well, there's the 4s, there's the 9s. We count 7. 7 out of 36. Reduced, it can't be reduced, so that is our probability of getting a perfect square. Part C, probability of not doubles. So these that are yellowed and circled in yellow are the doubles. Doubles means that both dice have the same number. So these are the doubles. So we want not doubles. So again, we could use the complement, not the doubles. Well, we know there's 36. 6 of them are doubles. So what's left over? That's right, 30 out of 36, which is 5/6, which we discovered in A. Last but not least, what's the probability, theoretical probability of a 9? So we've done 9s already. So the probability of a 9, we saw 9s over here. So 9, 9, 9, 9. How many 9s are there? That's right, there's 4 of them. 4 out of 36. So the probability of getting a 9 is 1 in 9. All right. So I think this is pretty relatively straightforward. If you have any questions, please ask. Let's continue. Example 6. A drawer contains 3 white socks, 4 black socks, 2 gray socks, all of the same style. 2 socks are chosen from the drawer at random. Describe the sample space using set notation. So here comes the hard part. You need to describe the sample space. So you start with the sample, S equals, now we're going to use some short forms, W, B, G for white, black, and gray. So you can have a combination of white and white 1, because there's 3 of them, white 1, white 2, white 1, white 3, white 1, black 1, white 1, black 2, and so on, so that you have all of the white ones possible to be picked out of the drawer. Now we've covered all the white ones. We have 2 more white ones to deal with, so white 2 now. So we have white 1 and all the blacks and all the greens. Whites, blacks, and greens all done. Next, white 2. White 2 was already combined with white 1, so we go to the next one. White 2 with white 3. White 2 with B1, and so on. So all the black socks, all the gray socks. And we're done all the white 2s in this sample space. Next, we want to deal with white 3. White 3 deals with we've done all the other whites with white 3. Now we're going to continue. white 3, black 1, white 3, black 2, white 3, black 3, white 3, black 4, white 3, G1, white 3, G2, and so on. So that's a lot. So we're just going to step back for a second, and we dealt with all the white 3s with all the other socks. Next, we deal with, okay, so we dealt with all the white 3s. Now we go on to the black. Black 1 goes with black 2, and so on, all the way across. So blacks deal with the rest of the black socks and the gray socks. Because we don't deal with the white ones because we already dealt with all the whites. The whites are finished. We're working with the black socks. Finish through the black socks. And then we move on. Once we deal with black 1, we go on to black 2 and deal with all the black 2 combinations. And then we go on to the black 3 combinations. And once we're done with black 3, we go on to the black 4 combinations. And once we're done with the black 4 combinations, we've dealt with all the black socks, so now we're left with the gray socks. Well, gray 1 can only go with gray 2. And guess what? That's the end of the entire problem, an entire sample set. So this is the sample space that you're looking for using set notation. Part B. Using set notation, show the different ways of choosing 2 socks that are the same color. So, going back to the sample space we had before, so I'm just going to quickly show them to you. What we want to do now is highlight the ones that were chosen. Okay, we want to highlight the ones that have the same color. So, white 1 and white 2, white 1 and white 3. Next, white 2 and white 3. Next, black 1, black 2, black 1, black 3, black 1, black 4, black 2, black 3, black 2, black 4, black 3, black 4, and finally G1, G2. So a total of, this is the entire different ways of choosing 2 socks that have the same color. So inside this set, I want you to write out these combinations. Next part. What is the theoretical probability that 2 randomly chosen socks will be the same color? And part D, what are the odds against 2 randomly chosen socks being the same color? So the set of the same color is as follows. Now, the next part is, what is the theoretical probability that the 2 randomly chosen socks will be the same color? Well, what we need to do is calculate that by saying, all right, I need the probability of the same is equal to the number of A possibilities. And if we look here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 possible same color combinations over the total sample space, which is 1, 2, 3, 4, 5, 6, 7, 8 here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So 8, 7, 6, 5, 4, 3, 2, and 1. We're adding all those numbers up. And what do we get? We get 36. So there's a 36 possibles in the sample space. The desired event is getting the same color. There are 10 of those, so 10 out of 36. Reduced will be 5 out of 18. Now, what are the odds against 2 randomly chosen socks being the same color? Odds against. Odds against, we want it to fail versus getting the same color. So what are we looking at? Well, odds against are 26 to 10. 26 is possible of not getting it to 10 possible getting it. So what are we looking at here? We're looking 13 to 5. 13 of actually not choosing the color to 5 actually choosing the color. Alright folks, that's the end of this video. Hope this helps. Have a numerical day.